This is the silo assignment. It's actually going to consist of 3 different parts. It'll have exercises 1, 2, and 3. Now to get to that, you're going to go into LogixPro. And so that's of course the little balloon program. I'll drag it over here. So LogixPro, I'm going to widen this up a little bit. The simulation is going to be silo. Let's open that up. And it looks like a little conveyor line. We have this box that we're going to fill up with parts, or with a material that's coming out of this silo. Here's our little valve that we're going to open up. Here's the level sensor. Here's a proximity sensor. Here's a motor that's going to control the belt. Here we have our buttons, start and stop button. And then we have different settings of A, B, C, and what those function as. And we're going to be looking at those as we go. And then we have our lamps, a run lamp, a fill lamp, and a full lamp. So to look at the exercise that matches it, if I go to help, and then student exercises, and then to silo simulator, here are all of the parts to it. So the first exercise says continuous operation. So completely design and debug a ladder diagram or ladder control circuit which will automatically position and fill boxes that are continuously sequenced along the conveyor. So sequence can be stopped and restarted at any time using the start and stop. Run light will remain energized as long as the system is operating automatically. The run light, conveyor motor, and solenoid will de-energize when the system is halted. So the run light stops when we hit the stop button and will turn back on. Fill light will energize when the box is filling. Full light will energize when it's full and remain that way until the box is moved clear of the Prox. So if we look at our first portion of it, we basically need to, when we hit the start button, the lamp turns on and the conveyor moves until we get to the Prox. So that's what I want to start with. Now you can do this many different ways, and I may move a little fast, but of course you can pause this or do whatever you want with it. I'm going to make this, if I grab start and drag it out, it'll tell me. If I move my mouse over top of it, it tells you it's off screen for you, but it's telling you I:1/0. But the inputs and outputs are different on whatever. So let's change this. I'm going to call this start PB for push button. And then I want that to actually turn on my run lamp, which is kind of funny. That's kind of what I'm going to use in my circuits to show if the run lamp's going, we can keep things moving. So I'm going to make that run lamp. All right, run lamp. And then I want to seal it on, so I'm going to put this parallel circuit in there and hold itself on. And I want it to stop when I hit the stop button. And I'm doing a examine if closed simply because I know the stop button is a normally closed button. And so when I push it, it will turn off the system. Or stop the system at least momentarily. But since I'm sealing it in, it'll stop this run lamp completely. Stop PB, peanut butter, push button. So now when I hit that button, it's going to stop. And I'm going to download it. And you see I came down here, download, run. Let's try that. It's on, it's off. So everything's working just like it should. But now I want to get this conveyor to just run across the system when I hit start. So I want run to be part of this next rung that is turning on the conveyor. Now, one important thing is this is the only line that's going to turn on the conveyor or the motor. Because if not, you're going to have multiple outputs on multiple lines telling it what to do. So let's download this and try it out. When I turn on the run lamp, it's flowing, but if I hit stop, everything stops. So if I look at that, that actually meets, not the right one, meets a couple of the requirements that meets here. The run lamp, conveyor motor, and solenoid will de-energize when the system is halted. Okay, when I hit the stop switch. So part of that's there. The run lamp light will remain energized as long as the system is operating automatically. That's true. Sequence can be stopped and restarted. Okay, so we have some of those. So now the big thing is I need to have it when I hit the prox, it stops the motor from running. So let's go ahead and I'll add an examine if open, because right now the prox is on until it's covered. And I think I can see it. It might tell me. It doesn't tell me, but this is a normally open prox sensor. And if we get to the prox sensor, the motor's going to stop. And I'm down here. The run light's still going to be on because once we pause, we have to fill this thing up. So I'm going to add Prox Sensor to it. So now when we hit the prox, it's going to stop the motor from spinning and nothing's going to happen. Now, a few more things that I want to turn on our outputs is we are going to have a solenoid valve turning on. We're going to have a fill lamp and a full lamp. So let's go start with the first one. We know that that's going to be a solenoid valve. Edit that, and I'm going to go solenoid valve. Oops, if I can spell it correctly, via valve. And then this will be the fill lamp. Edit that symbol, fill lamp. And then let's go with the full lamp. There we go. So we have those, fill lamp, full lamp. Now the full lamp will only be on as long as it's on top of the prox. Okay, so it had two things that it needed to match. It has to be when the box is full and until we're out of the way of the prox. So if we're on the prox and the box is full. So this is kind of fun. I'm going to say over the prox. Oops, wrong one. And the box is full. So we don't have anything that's saying that the box is full yet. I guess that's a level sensor. We'll leave this one alone right now. I know that's going to be when the box is full, but we don't really have anything saying that it's going to be full yet. We have the fill lamp, but that's it. So the fill lamp is only going to be on. Let's see what it says. Fill light will be energized when the box is filling. So only if the solenoid is on, the fill lamp is on. We know that. So solenoid is on, fill lamp is on. We're not quite sure with the full lamp yet because we have to get that figured out. But what's going to turn on the solenoid valve? Well, we know if our level sensor is full, we need to turn that thing off. But, we better think about how we want to trigger that on. I know that it can only work when, one, the motor is not spinning. So let's say motor is off, because we shouldn't be filling when the motor's turning. So it needs to be stopped. It needs to be not full. So it's not full. We don't have anything saying it's full yet. I guess that's the level sensor. Not. Do I have the level sensor on here yet? I don't. So, and the level sensor, okay, so the full lamp comes on when the prox sensor and the level sensor come on. Now, one thing that I kind of want to do is the level sensor is supposed to stay on until we leave the prox sensor, which means I kind of need to use something else besides this level sensor to say it turns on. Now, this is going to be a little interesting. I want to come out and say, and this is just another rung, it's going to be a little interesting. I want to say when the fill lamp, when the level sensor comes on, I want it to turn on a bit. Now, in connected components, we would just create our own tag and call it full bit or full. But in here, we don't have that option, so I have to come and grab an internal bit, which we played with before, these binaries, and I'm going to grab one of these. We used it as a ready bit before, and I'm going B30. So I'm going to grab B30, and I'm going to call this full bit, just so I know that when it's full, it's going to stay on, and that's where I'm going to put it in this loop to hold itself on. Full bit is going to hold itself on until we're past the prox. So what's going to turn it off? The prox. So I'm going to say if the prox sensor is on, we're going to say that the full bit level sensor's hit, so it's going to hold it on, which is kind of cool. But if I look up here, one thing that I have to notice is I want not level sensor to turn on the full amp. I want the full bit to turn on that. So let's go change the level sensor to full bit. Now, where else did I say the level sensor? Solenoid valve, once it hits it, it triggers it, and it should kill it. So as long as that's on, in fact, instead of level sensor, why don't we say that is the full bit as well? So what turns on the full bit? Level sensor tags it, turns on the full bit, and everything shuts off. Let's see what's going to happen right now. I know we're not done with it, but uh-oh. Stop. Stop. Oh no, clean up. What was I doing wrong? My solenoid was turned on when the motor is off and the full bit's on. Clean up. Let's take it out of run mode. Dang it. I need to make it so that the solenoid can only turn on when we're over top of the prox. That's kind of important. So I'll move that to the front since that's so important to me. It can be anywhere in the line, but the prox better be on there. Prox is on, motor is off. We're not full yet. We're not going to get full by filling up the room. So now let's try this. Okay, it's not running. Stops. Fills. It stopped. That's awesome. Now, one thing that we have to look at is we need to get this motor running. And when can the motor be running? The motor can be running when we have the prox sensors off, but we're going to have to bypass that because that's killing it. So let's throw in a parallel circuit and yeah, because it's going to have to make its way past the prox to go. So let's say it can run if the bin is full and then the solenoid won't run as long as it's full. Oh, let's try it out and see. Maybe we have it figured out. I don't know. Or it'll be a mess. We're full. I can hit start. Fills up. Actually, this is looking pretty cool. I'm going to speed it way up just in case something's getting right. And you can see it's slowly picking up, which means for some tiny instance, it is shooting a little bit of liquid down when we are in between the level and the prox. So let's go look at the solenoid valve. It's saying, but see, right now, our full bit should be on. Oh, but our full bit is on. That's preventing the solenoid valve from going. So the full bit is going to, for one little tiny bit, turn off. Let's go look at that. It might be because this rung, let's get out of that. This rung should be before we're turning on stuff. So let's try that. I'm just going to move it up there and see if that makes any difference. Download that, run. Let's see what happens. I don't see it filling. Now, this is a bug that you might find, and it's kind of crazy. And in real life, you'll probably never notice it. But that split second, if we don't put the full bit before we're using the full bit down here for the solenoid, it's going to dump a tiny bit every cycle. Now, in reality, we would never see that. But in the program, because everything is instantaneous, we would see it. So if I hit stop, the full amp is still there, full amp not there. Did we see anything that if we turn it off, the full amp should go away? When the box is full, and will remain that way until the box is moved. Okay, we're good. Fill light when the box is filling. Run light when everything's on. Stops. Run light will remain energized as long as the system is operating automatically. The sequence can be stopped and remounted any time. Okay, so in reality, I'm going to go and I better go back and clear this simulation, reset simulation so it's not a mess. Download, run. So if I hit start, everything's going. Let's slow that down to make sure it seems like it's doing filling, and it's full. Stays full until it goes past. Oh my gosh, it's working like it should. This is really cool. Now, so this is basically exercise 1. Now, I understand you might have to pause it, slow it down, whatever it happens to be. And the little video will hopefully help for that. You don't have to do it the same way I did. You can make it any other method, and I'm sure you can find a bunch of movies on YouTube to help you out. But this way works pretty slick. I did not go reference anything for this. I just kind of did this on the fly as we went. So I know if I looked at last year's or the year before's or the semester before's, they are not going to look exactly like this. So I'm going to go ahead and stop this, and we'll start exercise 2.